Okay, so the first question you had here was algebra. The first part of the question we have 10 marks. The next part there's 10 marks for the long division and then 5 marks for the last bit. In the first part here it says find the expression independent of x in the expansion of x plus 1 over x to the power of 8. So you could use binomial theorem, you could use Pascal's triangle, it doesn't really matter. I've worked out my 9 different terms here. Once you've worked it out, basically you need to figure out in which one of these terms are the x's going to cancel each other out. Like say for example this one, you should view this one, this is x to the power of 6, 1 over x to the power of 2. You should just view that as an x to the power of 6 on the top and an x to the power of 2 on the bottom. So the one in which all the x's are going to cancel each other out is this one. If you take, it's your 5th term, 8 choose 4, x to the power of 4 by 1 over x to the power of 4. This was the term we're concerned with. Because if I simplify that, 8 choose 4 is 70. X to the power of 4 is just an x to the power of 4, but 1 over x to the power of 4 is the same as, you can just put the 4 like that. So it's a 1 over an x to the power of 4. In other words, you have an x to the power of 4 on the top, an x to the power of 4 on the bottom, so the coefficient of the term that's independent of x is 70. So your 10 marks in that case, we're going for 70. Okay, so like I said, there was 10 marks here for B part 1. We are told that this quadratic is a factor of this cubic. So if that's a factor of that, then if I divide the quadratic into the cubic, I know the remainder is 0. So let's just go through the long division bit here. I'm going to divide x squared into x cubed. And x squared into x cubed is going to go x times. Then I'm going to multiply x by these 3 terms. X by the first one gives me x squared, x cubed. X by the second one gives me bx squared. And x by c gives me cx. Your third step in your long division is you have to subtract. So I get a minus, and a minus. Now my x cubes are going to cancel each other out, and this is the point where you have to be careful. You shouldn't write it as px squared minus bx squared. Mathematically it's not wrong, but rather than writing it as 2 terms, you need to write it as 1 term. You're much better off to factorize out your x squared. So rather than writing it like that, you're better off to write this as p minus b times x squared. It just makes for a much easier question. Here I've got qx minus cx. Rather than writing that as 2 terms, I'm going to write it as q minus c times x. And then the last step in your long division is you take down the next term. Now we just start our process all over again. X squared divided into p minus b times x squared, we'll just go in p minus b times. Your second step is you're going to multiply. So you're going to multiply p minus b by those 3 terms. And this is the stage where it gets pretty messy. So this is actually the easiest line, because you're not actually going to multiply anything. You're just going to list out the letters. So p minus b by x squared, you're just going to list it as p minus b times x squared. P minus b by bx, again, you're just going to write it as a list. It's just p minus b times bx. And then p minus b times c will just work out as p minus b times c. Happy days, that's my multiplying step. Now I just need to subtract. So I get a minus there, I get a minus there, and I get a minus there. My x squareds will cancel each other out. And at this stage, you should split your question into 2. Your first remainder are the coefficients of x. The number in front of x on the top is q minus c. And the numbers in front of x on the bottom are minus times p minus b times b. You know the number in front of x on the top minus the number in front of x on the bottom must be equal to 0. And you can do the same thing here. The number on its own on the top, which is minus 4, and the number on its own on the bottom, which is minus p minus b times c, will also be equal to 0. So now you have 2 different equations, and we should be able to work it out and get to our 2 answers. So to get the full marks for B part 1, I just need to simplify this one. All I was asked to do here is isolate my minus 4. If I just bring this term to the other side, it becomes plus times b minus p times c. And that's your final answer. That's all you were asked. So you're 10 marks there for B part 1. Now for B part 2, there was 5 marks for manipulating this one. The first thing you have to realize is that in your answer, you want a q, a c, and a b. But you got to get rid of your p. So I don't want to have a p here at all. Which means that on this side, you can isolate p and sub it in. But in fact, it's actually easier. You can isolate p minus b. If you just isolate p minus b on this one, you can sub that in. So suppose in here I just isolated p minus b. That means I'm going to divide both sides by c. I'll get minus 4 divided by c. That means that if I look now at this equation, instead of p minus b, I can just sub in minus 4 over c. And happy days, then I'll have the right letters. So in this case, I can just sub in q minus c minus, and then in my brackets, instead of that, I can just put in minus 4 over c. And I know this is progress because at least now I have the correct terms. So now obviously my immediate complication is the fraction. So you can just multiply everything by c. If you actually know, well, let's multiply out the bracket first. The first thing I can say is I have q minus c plus 4b over c. And now I can view it as my immediate problem is the fraction. So in order to get rid of that fraction, you're going to multiply everything by c. If you multiply the first one by c, you'll just get qc. If you multiply the second one by c, you'll get minus c squared. And if you multiply this one by c, you'll just get 4b. Now, all we were asked to do, if you look at the way we have to leave the question, I just want to leave the 4b on this side and bring everything else to the other side. So if I just bring everything else across, the qc will become minus qc, and the minus c squared will become plus c squared. So 4b is equal to c squared minus qc, which is what I was asked to prove. Okay, now the first part of question 2, there seems to be a lot of confusion here. There was 15 marks going for getting your diagrams right here. So let's look at just the first function, the function f. Remember, if it's a line, it's implied that it's going on forever in that direction and forever in that direction. I could draw a horizontal line anywhere on this graph in which it would intersect the graph at least once, it would intersect the graph at most once, so it passes both of my horizontal line tests, which means that it is injective, it is surjective, and by extension it is bijective. So for that one, you have to tick all 3 boxes: injective, surjective, and bijective. Any horizontal line on that graph will intersect it at least once, and it will intersect it at most once. Okay, now let's turn our attention to part G. First of all, I could draw a horizontal line here. A horizontal line there intersects the graph twice, which means it fails our test for intersecting at most once. On the other hand, I could also draw a line here. If I drew a horizontal line here, it fails my test for intersecting at least once. So it doesn't intersect it at least once, it doesn't intersect it at most once, so it's not injective, it's not surjective, and it's not bijective. So in that case, all 3 of 3 x's, they're all false. All 3 of them are false there. Okay, the third graph, H, I'm given a restricted domain and codomain. It says or plus and or plus. That implies you're only including positive real numbers. So obviously this time I'm not allowed to draw a horizontal line down here because that's not part of my domain or my codomain. I have to draw a horizontal line above the x-axis. So if I draw a horizontal line anywhere on that diagram, it will intersect the graph at least once, it will intersect the graph at most once, so that means it is injective, it is surjective, and by extension it is bijective. So your graph of H, it also passes all 3 of your tests. It intersects it at least once, it intersects it at most once, which means that it passes injective and surjective, which means it's also bijective. Okay, there was 10 marks going for part B here. We're given the function f of x, h of x, and g of x. We're asked to get f of h of g of x. They've put in the little circles, but it's the same as this. The way they've written it in the question is the same as asking you for f of h of g of x. It's a little bit easier for them to write it like that because this is a messy format. Ultimately, I need to use the function f and get f of h of g of x. So obviously the first thing I want to do is actually work out what is h of g of x. So that's my subsection here. I need to get h of g of x. Clearly that means I'm subbing into the function h, which is 2x minus 1. Except instead of an x, you're going to sub in g of x, which is 4x minus 3. So you're subbing in to this. You're subbing into 2 times x minus 1, except instead of an x, you have to sub in g of x. So all I've done is subbed in 4x minus 3 into that x. If you simplify that down, it works out as 8x minus 7. So h of g of x is just 8x minus 7. Which means that instead of looking for f of h of g of x, I can now actually just call that f of 8x minus 7. Once you get to there, it's relatively straightforward. You're subbing into the function f, which is x squared plus 2x, except everywhere there's an x, you're subbing in 8x minus 7. It becomes 8x minus 7 to be squared plus 2 times 8x minus 7. You multiply it out, and your final answer is 64x squared minus 96x plus 35. And there's 10 marks going for that. Okay, there's 15 marks going for 3-part A again. I just want to point a few things out to you here. First of all, everyone in the country doing higher level maths will be aiming for full marks in this. So they're going to be really strict on how it's marked. A very common mistake between all of you was a lot of people got minus 4 by plus h and ended up with a plus 4h. A lot of people ended up with a sign error from there and ended up with a plus 4 there. First of all, you should be able to look at the question and see what the answer is. So if you ended up with a plus 4, you should have realized you've made a sign error. You should write your last line as the limit as h approaches 0 of all of that. A lot of people are just writing the limit bit. You need to write the whole thing. The limit as h approaches 0 of f of x plus h minus f of x over h. And remember, you cannot sub in the h. To go from the second last line to the last line, you never sub in the h. Because h is not actually 0, it's just approaching 0. It's really, really close to 0, but it's not actually 0. So if you sub in 5 times 0, you're wrong. You'll lose the marks for that. Despite some of the marking schemes, if you look them up online, are wrong. If you sub in 0, then you'll lose marks. So you should be getting full marks in that. Okay, we have 10 marks going for question 3, part B. We're given the function x times x plus b to be squared. We're told that the derivative is equal to 0 when x equals 2. So the first thing you should do is just multiply this out. Always try and simplify it first. A load of people went for the product rule first. It will work, but it's much, much harder. Always try and make your life a little bit simpler if you can. So if you simplify this out, it works out as a cubic. X cubed plus 2bx squared plus b squared x. Once you have your function simplified fully, it's very straightforward to factorize it. Sorry, not to factorize, to differentiate. The derivative of x cubed is 3x squared. The derivative of 2bx squared, you bring the power of x in front, becomes 4bx. This is the one where you're likely to make a mistake. You have b squared x to the power of 1. You're not getting the derivative of the b. So the power of b stays the same. Remember, b is just a number. So getting the derivative of b squared x is the same as getting the derivative of 10x. The derivative of 10x is just 10. The derivative of b squared x is just b squared. Because all you're doing is bringing the power of x in front, 1 times b squared, and then the power of x decreases by 1 and becomes a 0. So the derivative of b squared x is just b squared. Because you're differentiating the x, not the b. So your first derivative is that. And I was told that the derivative equals 0 when x equals 2. So if you sub in 2, you get b squared plus 8b plus 12, and you know that that's equal to 0. So obviously you have just a basic quadratic, you factorize it and you solve it. Your two answers are b equals minus 6 and b equals minus 2. Okay, so in general, most people did well in the first part of question 4. There's 5 marks going for integrating this and applying the limits 1 to 0. If you integrate it, it works out fully as x cubed minus x squared plus 4x. You just sub in your limits from 1 to 0 and your final answer is 4. Okay, the second part of this question people found a little bit trickier. There's 5 marks going for this, and you're asked to get the integral from pi over 2 to 0. Okay, I did it right. Okay, now the second part of this question, students found a little bit trickier. There's 5 marks going for part B. You're asked to integrate sine 3x cos 2x from pi over 2 to 0. Now there's no product rule on the course. We've never done anything where you're integrating a sine by a cos, which means you have to simplify this somehow. Obviously that means you have to go to your log tables, look for the trigonometry pages, look for a formula that will allow you to simplify sine 3x cos 2x into something that you can integrate. On page 15 in the log tables, it says that 2 sine A cos B is equal to sine A plus B plus the sine of A minus B. Based on that formula, that means that 2 sine 3x cos 2x is equal to sine 5x plus sine x. You add the angles together and then you subtract the angles. Add 3x and 2x, you get 5x. 3x minus 2x, I get 1x. But we don't have 2 sine 3x cos 2x. There's no 2 in front of it, so I can't use that. I've only got 1 sine 3x cos 2x. So if I've got half of the left-hand side, means you have to get half of the right-hand side. So based on that logic, sine 3x cos 2x is equal to a half times the sine of 5x plus sine x. Okay, and that's what I can sub in here. So instead of integrating sine 3x cos 2x, I want to get a half the integral of sine 5x plus sine x. My limits are staying the same. So I leave my half outside, and the integral of sine 5x is minus cos 5x divided by 5. The integral of sine x is just minus cos x. Then all I have to do is apply my limits. I sub in pi over 2 first, and then I sub in a 0. And it's a half times all of that. If you plug it into your calculator, your final answer is 3 over 5. Okay, so there's 5 marks going for question 4, part B as well. In this part, we're asked to integrate e to the x times e to the 2x minus e to the minus 3x. Again, we've never done anything with product rule. We've never done anything where we're getting multiples of exponentials, so you have to be able to simplify it first. You can use the first rule of powers in your log tables. A to the power of p by a to the power of q means just add the powers together. So e to the power of x by e to the power of 2x, I just add them together. X plus 2x is 3x. And same on the next one, x minus 3x is minus 2x. So I actually just need to get the integral of e to the 3x minus e to the minus 2x. The integral of e to the 3x, it stays the exact same, and then I divide by the derivative of my power, which is 3. Minus e to the minus 2x stays the exact same, and I divide by the derivative of the power, which is minus 2, and I add c this time because there's no limits. All you have to do then is a minus multiplied by minus gives you a plus. So that's your final answer there, that's your 5 marks. Okay, the start of question 5 here is 10 marks going first, and we're given this quadratic. It's 3 to the power of 2x plus 2 minus 28 times 3 to the power of x plus 3. Now, you have to recognize that this is a quadratic. They've given you a hint in the question. They've told you to let y equal to 3 to the power of x, which means I've no bother. My middle term is obviously just minus 28y. My last term is a 3. The problem lies in the 3 to the power of 2x plus 2. Now you should work it out in your rough work. 3 to the power of 2x plus 2, that's the same as 3 to the power of x plus a. Then we're using that rule of powers that always pops up again and again. 3 to the power of x plus a is the same as 3 to the power of x by 3 to the power of x by 3 to the power of 2. And instead of 3 to the power of x, I can put in my substitution, so it's y by 9, so I end up with 9y squared. Which means I can now rewrite my quadratic as 9y squared minus 28y plus 3. You factorize it and you get y equals 1/3, you get 9y minus 1 times y minus 3. If you solve it, you get y equals 1/9 and y equals 3. So you manipulate it down, that means that x works out as minus 2 or x works out as 1. There's 10 marks going for that. Okay, for question 5 part B, we're asked to prove by induction the sum of the squares of the first n natural numbers is equal to this. Now just bear in mind, in the leave insert, they don't have to give you that left-hand side. They don't have to say that they're actually talking about 1 squared plus 2 squared plus 3 squared the whole way up to n squared. If they just say the sum of the squares of the natural numbers, you need to be able to come up with that yourself. It's the square, you square all the natural numbers and you add them together the whole way from 1 to n. Okay, now a series induction question has never come up, so it's vitally important that you're clear on this. Right, the first thing you're going to do is you're going to test for n equals 1. You need to understand that in these series questions, the thing that varies on the left-hand side is the number of terms. If I was subbing in n equals 3, that actually means that you're subbing in 1, then you're subbing in 2, and then you're subbing in 3. If you subbed in n equals 3, the left-hand side would be 1 squared plus 2 squared plus 3 squared. If you subbed in n equals 5, the left-hand side would be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. There'd be 5 terms on the left. So if you sub in 1, technically what you're doing is you're subbing into that. This is your general formula. Remember, whatever comes at the end there, that's your general formula, Tn, and that's your sum of all your terms, Sn. But I suppose you've already got the first term, so you could just write it down as it's 1 squared. And on the right-hand side, you just sub in a 1, you end up with 1 equals 1, so happy days, it's true for n equals 1. Now you need to do your assumption. The assumption is the easiest part. You need to assume that n is equal to k. And in this case, just like when I wrote out this line, we didn't know how many terms there was. We don't know what n is. N could be a million, it could be a billion. But the point is, you just say 1 squared plus 2 squared plus 3 squared the whole way up to n squared. I have the exact same issue with my k. K could be a million, it could be a billion, it could be anything. So all I can say is 1 squared plus 2 squared plus 3 squared the whole way up to k squared. And on the right hand side, you just sub in your k. So I want you to notice that your assumption is the exact same as your question. You've literally just subbed in a k instead of an n. So you can just view it as you're just subbing in. But now it's the first line of your third step that's vitally important. Let's imagine that k was equal to 50. If k was 50, that means that there's 50 terms on the left-hand side of your assumption. And if k is 50, that means that there's 51 terms when you sub in k plus 1. So what you need to do is write out the first 50 terms exactly as you had it here. So you rewrite your assumption. 1 squared plus 2 squared plus 3 squared, the whole way up to k squared, which is exactly what I wrote here. And then you just add one more term. To figure out what your new term is, remember you're subbing into your general formula. So it's the exact same as your assumption plus one more term. Again, the right hand side, you just sub in k plus 1. Now, when you get to this line, like, that's gibberish. You've got a dot, dot, dot in the middle of it. You're never going to prove that an unknown amount of terms is equal to a fraction. So you have to get rid of that series bit as soon as you can. So straight away, you sub in for your assumption. Instead of 1 squared plus 2 squared plus 3 squared the whole way up to k squared, I can sub in what I had in my assumption. I know that that's actually equal to k times k plus 1 over 2k plus 1 over 6. Times 2k plus 1 over 6. And all of a sudden now you've just got basic algebra. It's just fractions. Every single series induction question will be identical as far as this line. And it's only here where things start to vary. So now we just need to manipulate it and try and get the same thing on the left as on the right. So all I'm doing here now is I just need to make sure the left hand side and the right hand side are the same thing. So I'm viewing my immediate complication as my fraction, so I multiply everything by 6. If I multiply this one by 6, then the fraction is just gone. If I multiply that one by 6, it's just 6 times k plus 1 to be squared. And on the right hand side, the fraction is just gone. If you multiply that out, you'll end up with 2k cubed plus 9k squared plus 13k plus 6 equals the same on the right hand side. So I can just conclude and say that it must be true for n equals k plus 1. Once you've proven that, that's all your maths. You make sure you make your conclusion that the proposition is true for n equals k plus 1 if it is true for n equals k. But we know it's true for 1, so therefore it must be true for 2, 3, 4, and all the other natural numbers. Okay, there's 5 marks going for the last part of this question, where we're asked to get the sum of the squares of all the natural numbers from 30 to 60 inclusive. Now, a lot of you made a silly mistake here. Notice that this is the formula you're using. Obviously, this is the sum of the squares of the natural numbers. And in order to get from 30 to 60, I need S60, the sum of the first 60, minus S29. If I get the first 60 and I subtract the first 29, I'm left with 30, 31, 32, 34, the whole way up to 60. A lot of people made the mistake and they went S60 minus S30. But that means you're not including your 30. I need to say S60 minus S29. You just plug it into your formula and your value works out as 65,255. Okay, so for question 6 here, there's 10 marks going for part A. In part A, we're told that Z is equal to minus a half minus root 3 over 2i. And we're asked to write this in polar form. In order to write a complex number in polar form, it needs to be in the form or cos theta plus I sine theta. So obviously the two things I need to do here is find the value of or, find the value of theta. Or stands for the modulus, and the modulus is calculated as the square root of a squared plus b squared. In this case, my a is minus a half and my b is minus root 3 over 2. So if I get the square root of a squared plus b squared, my modulus in this case works out as 1. In order to get your argument, your theta, you have to draw yourself a diagram. So you'll notice here I've labelled my horizontal line as the real axis, my vertical line is the imaginary axis. This is roughly minus a half, that's roughly minus root 3 over 2. Doesn't really matter where you draw it, it doesn't have to be to scale. And you're looking for the angle, so you form a right angle triangle by joining the coordinates, your complex number, to the origin and then directly up to the x-axis or into the real axis. You're looking for the angle that it makes with the real axis. And you should notice that you know that the opposite here is root 3 over 2, you know the adjacent is a half. Now a lot of students mixed up your opposite and your adjacent. To get the tan of an angle, it's opposite over adjacent. So in this case, it's root 3 over 2 divided by 1 over 2. Remember, your opposite is a distance and your adjacent is a distance, so you shouldn't be using signs there. You don't put in a minus. It's not a minus over a minus. They're distances, so they're positive. If you get tan inverse of all of that, your angle A works out as 60 degrees. But the argument, the angle you're looking for, theta, is the angle that it makes with the positive sense of the x-axis. In other words, this angle. Now you need to think of your trigonometry here, think of your ASTC. In order to get an angle in the third quadrant, it's 180 plus your reference angle. So in this case, 180 plus 60 gives me 240 degrees. So your theta in that case is 240. Now that you know your or and you know your argument, you can write the original complex number in polar form. Your final answer here is it's 1 times the cos of 240 plus I times the sine of 240. So your final answer, your 10 marks there, goes for writing out your complex number in polar form. Okay, for question 6 part B, I think students seem to struggle a bit with this one. There's 10 marks going for this as well. We're told that w to the power of 4 is equal to z. We're asked to find the value of w. So we need to find the 4 different values for w. If w to the power of 4 equals z, then obviously w is equal to z to the power of a quarter. And in the previous part of the question, we've worked out that z is the same as 1 times cos 240 plus I times the sine of 240. So I want to get that to the power of a quarter. Now you need to recognize that if you have a complex number in polar form to the power of a quarter or to the power of a fraction, that means there's more than one answer. In fact, here it means there's 4 different answers. If you're going to get 4 different answers, you have to generalize your angle. So in the next line, before you apply your de Moivre's theorem, you have to rewrite the angle as 240 plus 360n and 240 plus 360n. Now obviously if you were dealing with radians here, that was fine. They never specified whether you used degrees or radians. If you had been dealing with radians, you would be adding 2n pi. Once you've generalized your angle, now you can apply your de Moivre's theorem. It'll be 1 quarter to the modulus to the power of a quarter. 1 to the power of a quarter is just 1. And then you multiply the angle by the power. So 240 by 36 plus 360n multiplied by a quarter is basically just a 4 underneath. Same on this one. So you just put a 4 underneath your angle. If I divide 4 into both of those, I get 60 plus 90n and 60 plus 90n. That is it simplified fully in polar form. But I need to get to 4 different answers in rectangular form. In order to get them in rectangular form, I sub in n equals 0, n equals 1, n equals 2, and n equals 3. To be honest, you can sub in whatever you like. If you sub in 4 consecutive natural numbers, you'll get the 4 right answers. But obviously the easiest numbers to sub in are 0, 1, 2, and 3. So I want you to sub those in now. You're subbing in 0, 1, 2, and 3 into that, and just make sure you get the right answers, and I'll do it on the next slide. Okay, so to finish this one off, I just need to get my 4 different answers in rectangular form. If I sub in n equals 0, I get 60 and 60, in which case my answer is a half plus root 3 over 2i. If I sub in 1, I get 150 and 150, and I get minus root 3 over 2 plus a half I. If you sub in 2 into this, you get 240 and 240. Your answer is minus a half minus root 3 over 2i. If you sub in 3 into this, you get 330 and 330, which is root 3 over 2 and minus a half I. If you had continued on and subbed in 4, you would have ended up getting the first answer again. If you continued on again, you would have got that one. The next one would be that one. So basically the 4 answers just repeat themselves again and again and again. You know that there's 4 answers because it was to the power of a quarter. If it was to the power of a fifth, you would have had 5 answers. So your final answer, there's 10 marks going there for those 4 answers. Okay, we've got 5 marks going for the last part of this question. So 5 marks for part C here. You gotta know where you're starting off in this one. Ultimately, I need to prove that sine 3 theta is 3 sine theta minus 4 sine cube theta. It's very, very similar to the one that came up in your last test. You have to know you're starting off with a complex number to the power of 3. Cos theta plus I sine theta to the power of 3. And we're going to expand that by 2 different acceptable mathematical methods. One way of doing it is you can just do it by algebra. So on the left hand side here, I've multiplied it out using algebra. You can actually literally multiply it by itself 3 times, or you could use Pascal's triangle, or you could use the binomial theorem. But either way, when you multiply it out, you get cos cubed theta plus 3i cos squared theta sine theta minus 3 cos theta sine squared theta minus I sine cubed theta. On the right hand side, you multiply it out by using de Moivre's theorem. According to that, you just multiply the power by the angle. You get cos 3 theta plus I sine 3 theta. So the left hand side and the right hand side are acceptable ways of expanding the original line, which means they're obviously equal to each other. Now, if you're asked to prove the sine 3 theta proof, you now need to let the imaginary number on the right equal to the 2 imaginary terms on the left. The imaginary terms are the ones with the i's in them. So this one is 3i cos squared theta sine theta, and that one is minus I sine cubed theta. It must be equal to the imaginary term on the right, which is I sine 3 theta. Now, because there's an I in all 3 terms, you can just divide everything by I, and all of my i's just cancel. You need to recognize on this line that you've got to get rid of your cos squared theta. Clearly in my answer I only have sines, so I need to get rid of the cos squared theta. The top right hand corner of page 13 in your log tables, it tells you that sine squared theta plus cos squared theta equals 1. Based on that logic, if you isolated cos squared, if you brought the sine squared to the other side, you'd end up with cos squared theta is equal to 1 minus sine squared theta. So if you sub that one in, you just get 3 times 1 minus sine squared theta times sine theta. And then you have a minus sine cubed theta, and it's equal to sine 3 theta. If you multiply it out, it's relatively straightforward, and you get to your answer. So there's 5 marks going for that one. Okay, so for question 7, we're given 20 marks for each bit. So there's 60 marks altogether. Now, I know you only have to attempt 3 parts, but I want you to fill in all 5, because for your Leaving Cert, you should have been able to do this whole question. For the first one, it was relatively straightforward. There's 20 marks going for your 2 different fractions. You have 2 plus 1 over x divided by 2x squared plus x. On the bottom, for the moment, we're going to do nothing, but on the top, you're adding 2 fractions together so you can get a common denominator. I've done that on the right-hand side. If you're adding, you could view that as 2 over 1 plus 1 over x. If you're getting a common denominator there, your common denominator is x. And then you have to ask yourself, right, so the first fraction here is 2 over 1. How many times does 1 divide into my common denominator? 1 divides into my common denominator x times, which means it's going to be x multiplied by what was above the 1, which is a 2. My second fraction, how many times does x divide into the common denominator? X divides into x once, which means it's 1 times whatever was above the x, which is also a 1. So if I simplify that fully, I get 2x plus 1 over x. So all I've done on this line now is I've rewritten the whole thing. I can rewrite the top as 2x plus 1 over x, and I can rewrite the bottom as 2x squared plus x over 1. Now in maths, we never really want to be dividing one fraction by another. So rather than dividing by this fraction, you can invert the fraction and multiply. Dividing by 2x squared plus x over 1 is the same as multiplying by 1 over 2x squared plus x. And at this stage, we can simplify the right fraction here by just factorizing out what's common on the bottom. If you factorize out x, you're left with 2x plus 1. Then you have a 2x plus 1 on the top, a 2x plus 1 on the bottom, so they cancel. On the top, you're just left with 1, and then on the bottom, you're left with x multiplied by x, which is x squared. So there was 10 marks going for that bit. Now let's talk about the next one. Okay, so there's 10 marks going for the next bit here as well. You have a plus b divided by 1 over a plus 1 over b. Clearly what we should do here is simplify the bottom of that fraction. The bottom of the fraction, 1 over a plus 1 over b, you're adding fractions together, so you need a common denominator. The common denominator is just a multiplied by b. Then you ask yourself, how many times does a divide into the common denominator? A divides into this b times, which means it's b times whatever was above the a, which is a 1. Then you ask yourself, how many times does b divide into the common denominator? b divides into this a times. So that means it's a times whatever was above the fraction, which was a 1. So simplified fully, I just end up with b plus a over ab. So I can rewrite the original question, I can rewrite the bottom as b plus a over ab. Now at this line, you have to realize that instead of dividing by that fraction, you can flip it and multiply. So rather than dividing by b plus a over ab, you're going to invert it and multiply by ab over a plus b. And in that case, you should recognize that this is a plus b over 1, and that there's an a plus b on the bottom here. So the a plus b on top and the a plus b on bottom cancel, and all you're left with is the top here, which is ab over 1. So your 10 marks there in that case are just going for that. Okay, so again for part B, there's 20 marks going. It was 5, 5, and then 10. The first part here, you're given un, you're given your general formula, you're asked to find 1, 2, 3, 4, and 5. So you just sub in your values, and you should have gotten -4, -2, 14, 82, and 326. 5 marks going for that bit. Okay, so for the next bit again, it was relatively straightforward. You're asked to sub into u3 is -5 times u2 plus 6 times u1 equals 0. Now u3 is 14, u2 is -2, u1 is -4. So if I just sub in, I end up with 24 minus 24 equals 0. Clearly 0 is equal to 0, so that one's true. There's 5 marks going for that as well. It's the next bit that's really important. Okay, now there's 10 marks for the last part of B, and this is the way that iterative equations used to come up. So if you didn't get this right, make sure you pay close attention. So we need to investigate an expression that has un in it, it has un plus 1, and it has un plus 2. So before you even entertain the expression, the first thing you should do is, right, that's my un, it's given in the question. But you should simplify un plus 1 as much as you can. So I've subbed in un plus 1. Basically means into the expression for un, everywhere there's an n, you're putting in n plus 1. Now to simplify this, you should rewrite 3 to the power of n plus 1 as 3 to the power of n by 3 to the power of 1. 2 to the power of n plus 1 is 2 to the power of n by 2 to the power of 1. You are not allowed to multiply out 3 to the power of n. 3 to the power of an unknown is bad news, you just leave it be. In the first term here, you're allowed to multiply 2 by 3. If you multiply 2 by 3, you get 6. So it's just 6 times 3 to the power of n. You're allowed to multiply the -5 by the 2 to the power of 1, so you get -10 times 2 to the power of n. And you highlight, right, that's your un plus 1. When you get to the question, that's what you're going to sub in. You can do the same thing for un plus 2. It becomes 3 to the power of n plus 2, which is 3 to the power of n by 3 to the power of 2. 2 to the power of n plus 2 becomes 2 to the power of n by 2 to the power of 2. To multiply this out, you can multiply the 2 by 3 squared. 3 squared is 9, by 2 is 18 times 3 to the power of n. 2 squared is 4, by -5 is -20 by 2 to the power of n. Notice that we never touched anything with an unknown in the power. We haven't multiplied it out at all. We started off with a 3 to the power of n and a 2 to the power of n, and in each case we've ended up with a 3 to the power of n and a 2 to the power of n. And it's only at this stage that you should sub into your question. So once you've simplified un plus 2, un plus 1, and un, now you sub in. I need to prove that un plus 2 minus 5 times un plus 1 plus 6 times un is equal to 0. So un plus 2 is 18 by 3 to the power of n minus 20 times 2 to the power of n, minus 5 times what I worked out for un plus 1, plus 6 times what I was given for un. Now, so in the next line, we're just multiplying out our brackets. -5 by 6 gives me -30 by 3 to the power of n. -5 by -10 gives me +50. 6 by 2 gives me 12. 6 by -5 gives me -30. Notice again, I'm not multiplying out my 3 to the power of n's or my 2 to the power of n's. I've underlined the 3 terms here that are like terms. These 3 terms have 3 to the power of n's in them, so I'm just grouping them together. 18, 3 to the power of n, minus 30, 3 to the power of n, plus 12, 3 to the power of n. The other 3 terms on the previous line are all like terms as well. 2 to the power of n, 2 to the power of n, 2 to the power of n. So I have minus 20, plus 50, minus 30. If I group all of these together, I end up with 30 times 3 to the power of n, minus 30 times 3 to the power of n, plus 50 times 2 to the power of n, minus 50 times 2 to the power of n. Clearly they're all going to cancel each other out. 0 is equal to 0, so it's true. There was 10 marks going for that bit. If you didn't get that right, that's really, really important, so make sure you spend a bit of time on it. Okay, there was 20 marks going for part C. In part C, we're asked to write 4.58 recurring as a fraction. So you should recognize that 0.58 recurring, 0.58, 58, 58, 58, going on forever is a geometric series. The first thing you should do is write this out as a bunch of fractions. First of all, that's 4.58 recurring is the same as 4 plus 58 over 100. That accommodates for the first 58, okay? 58 over 100. But then imagine if I've already accommodated for that, you can imagine that it's now 0.0058. 0058 is 58 over 10,000. Essentially, it's just 2 more decimal places, so it's just 2 more zeros. I've now accommodated for that one, and I want to accommodate for the next 58, which is 2 more decimal places further on, so it's 58 over 1,000,000. There's 2 zeros here, there's 4 here, and there's 6 here. So in other words, I'm saying that 4.58, 58, 58 is the same as 4 plus that plus that plus that, but obviously this goes on forever, which means you just say a plus and then dot 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 dot. So what I have in my square brackets here is a geometric series that goes on forever. In order to work out what all those fractions add up to, I need to get S infinity for the geometric series. I can say that my first term is obviously 58 over 100, and then my common ratio is the second term divided by the first term, which works out as 1 over 100. Once you have A and OR, you can sub into the formula for S infinity. S infinity is just 58 over 100 divided by 1 minus 1 over 100. 1 minus 1 over 100 is 99 over 100. Your 100s cancel, and you're just left with 58 over 99. So if the question had just been a 0.58 recurring, that's the same as 58 over 99. To accommodate for the 4 at the end, you literally just take that answer and add 4. Plug it into your calculator, and your final answer is 454 over 99. And there's 20 marks going for that one as well. Okay, for part D, the limits caught a lot of people out. Again, this is very straightforward. It's one of those things that can easily fall through the cracks when you're revising. Both of these questions were from the notes. Okay, you're given the limit as n approaches minus 3 of n squared minus 9 over n plus 3. If n is approaching a number, in principle all you have to do is sub it in. But the problem is, if you sub in minus 3 at this stage, you'll end up with minus 3 plus 3 on the bottom. In other words, you'll end up with a 0 on the bottom. The 0 on the bottom of a fraction is infinity, and you're not allowed to have it. So you can't have a 0 on the bottom of the fraction. You have to factorize the top first. If you factorize n squared minus 9, you get n minus 3 times n plus 3. It's the difference of two squares. In which case, the n plus 3 on the bottom and the n plus 3 on the top cancel out. Now, happy days. The question is actually, find the limit as n approaches minus 3 of n minus 3. And you just sub in. It's just instead of an n, you put in minus 3. So minus 3 minus 3. Your final answer, your 10 marks, is just for the answer minus 6. Okay, so there's 10 marks going for the next bit as well. There's just a bit of manipulation here. This is a completely different limits question. If it's n approaching a number, that in principle you just sub it in. But if it's n is approaching infinity, that means you need to divide every term by the highest power of n. But before we do that, we need to do a bit of manipulation. It was root 2n minus 3 over root 72n plus 4. You can rewrite that as just the whole thing in one square root. So it's the limit as n approaches infinity of the square root of that fraction. Now you can actually just put the limit inside the surd. So you can actually just write it as it's just the root of the whole thing. And for the rest of the question now, we can just ignore the square root, get the limit as n approaches infinity of the fraction, and then when we get to our answer, we just get the square root of it. So it's only from this point that we're actually using our limits. If n is approaching infinity, that means you have to divide every term by the highest power of n. The highest power of n in this case is just 1. So it's 2n over n minus 3 over n divided by 72n over n plus 4 over n. There's 2 terms on the top, 2 terms at the bottom, and I've divided them all by the highest power of n. The 2n over n, the n's cancel. 72n over n, the n's cancel. So that's the same as just 2 plus 3 over n divided by 72 plus 4 over n. Now imagine you're subbing in n equals infinity. If you subbed in n was infinity, you'd end up with 3 over infinity. In other words, you end up with 3 over an infinitely bigger number on the bottom. If the number on the bottom of the fraction is infinitely bigger than the number on the top of the fraction, then it's a really, really, really small number. bordering on negligible. So that number is so small that it might as well be a 0. So 3 over n is basically 0, 4 over n is basically 0. So this just becomes 2 over 72. You've applied your infinity, and anything that was over n just becomes a 0. 2 over 72 is the same as 1 over 36, and I now need to go back and accommodate for my square root. The square root of 2 over 72 is just 1/6, and there was 10 marks going for that bit as well. Okay, so let's look at part E. There's 10 marks going for the first bit, 10 marks going for the second bit. Hands down the thing that students didn't recognize. Loads of you didn't recognize it. The first 10 marks here are relatively straightforward, but it's the second 10 marks that are really important. You've been given h of x is 3x times the cos of 2x. This is algebra multiplied by trigonometry. The only way you're going to get the derivative of that is if you use the product rule. In this case, your u is 3x, so du dx is 3. Your v is cos 2x, so dv dx is minus 2 times the sine of 2x. In other words, it just becomes the sine of 2x minus sine 2x, and then you multiply by the derivative of the angle. The derivative of 2x is just 2. And if you're using product rule, the derivative is just u dv dx plus v du dx. If you sub that in, your final answer is minus 6x sine 2x plus 3 cos 2x. And it is not a coincidence that that term is the same as or similar to the next part of the question. Okay, to get the next 10 marks, you're asked to evaluate the integral of 6x sine 2x from pi to 0. Now, in fairness, it was probably a bit too tricky without the limits, so let's ignore our limits. We're giving everyone the full marks if you got to the stage before you applied your limits. So you need to integrate. They're asking you for the integral of 6x sine 2x. There's nothing on the course that allows you to integrate algebra multiplied by trigonometry. We've never done anything to do with a product rule. It's not on the course. So you need to realize that this is one of your antiderivative questions. Originally, we started off with h of x, and we worked out that the derivative of h of x was this. If the derivative of h of x is that, I can now say the opposite. If I integrated my answer, this is my answer. If I integrated that answer, I would end up where I started. Because obviously if you differentiate something and then integrate it, you'd end up where you started. So that's your first line here. You need to say that the integral of your answer, which was minus 6x sine 2x plus 3 cos 2x, the integral of that, if you integrated it, you would end up where you started, which was 3x cos 2x. So that's your first line, that's your first set of marks. The integral of your answer equals the original question. And the whole point of this was to get the integral of 6x sine 2x. So on the left hand side, I just want to isolate this term. So we can split this up into two different terms. First of all, we can rewrite this as the integral of minus 6x sine 2x dx. So I can write it as that, and then plus the integral of 3 cos 2x dx. All I'm doing on the left hand side there is splitting it up. Okay? I suppose here for this one I'll just factorize out my minus. I can just take the minus outside the integral sign. It's just the integral minus the integral of 6x sine 2x dx. And clearly that's the term that I want to end up with on its own on the left hand side, because that's the question. Which means I want to bring this term to the other side. I want to bring this one across. If it's a plus on the left, it'll obviously become a minus on the right. So I'll leave that term as it is, and the other term becomes a minus. So it'll be minus this instead of plus. And because there's a 3 inside the integral, I can just take it outside. So it becomes minus 3 times the integral of cos 2x dx. So notice here that it's minus the integral of 6x sine 2x. But the question has asked you for plus the integral of 6x sine 2x, which means that you just need to change your signs. I want that to become a plus, which means that that becomes a minus, and that becomes a plus. So the integral of 6x sine 2x dx is equal to that. But obviously, if you've been asked to get the integral of this, you can't give your answer in terms of another integral. So in order to finish this one off, you need to integrate cos 2x. So the left-hand side stays the same. It's the integral of 6x sine 2x dx. And this term stays the same. I don't need to do anything with it. It's just minus 3x cos 2x plus 3 times. Now I need to integrate cos 2x. If you integrate cos 2x, you get sine 2x divided by 2 plus c. In this case, if there was no limits, I'd add in a plus c. Okay? So I suppose I can just simplify this fully. My final answer is that the integral of 6x sine 2x dx would be equal to minus 3x cos 2x. I'll just write that a bit neater. I can write that as 3 over 2 sine 2x plus c. So notice we have an answer for the integral of 6x sine 2x, even though we didn't actually integrate it. I still have an answer for it. We decided to take the limits out there. It's never actually come up with limits before, so it was probably a little bit too creative. Okay, so for question 8 here, I think a lot of people are still struggling with the financial maths. This was a relatively easy financial maths question, so if you didn't do well on it, you've got a lot of revision to do in your financial maths. We're given 40 marks for the first page here. It was 10, 10, and 20. Okay, the first part here, there's 10 marks going for it. A lot of people overcomplicated this one. Meg borrows 60 grand from the bank, and she chooses a payment-free option, which means that she doesn't have to pay any of the money back for the first 18 months. So you can view this, and oh, it told me the interest rate is 4.75%. So suppose I asked you, how much money will she owe them in a year? If I asked you how much money she'd owe them in a year, it would just be 60,000 times 1.0475 to the power of 1. That would tell me how much money she owes them in a year. The yearly interest rate would have been charged once. That's all you would have had to do. So if I ask you how much money will she owe them in a year and a half, rather than getting the yearly interest rate to the power of 1, I just get the yearly interest rate to the power of 1.5. If you plug that in, after a year and a half, she borrows 60 grand and the bank are charging 4.75% interest. After a year and a half, she's going to owe them 64,325.37 euro. So that's all you had to do that time. For B part 1, we're asked to find the annual interest rate that is equivalent to a monthly interest rate of 0.425%. We're asked to leave our answer to 5 significant figures. So you've done loads of these. I'd always set them up with the same template. I know the yearly interest rate to the power of 1 is equal to the monthly interest rate to the power of 12. I can write the yearly interest rate as 1 plus I to the power of 1, and the monthly interest rate 1 plus I to the power of 12. I would earn the monthly interest rate 12 times over the course of a year. I would earn the yearly interest rate once over the course of a year. And this time it's in reverse. We've been given the monthly interest rate. If they told me the monthly interest rate was 0.425%, then that means you want it as a decimal, not as a percentage. So you divide by 100, and that's equivalent to 0.00425. So 1 plus 0.00425 is 1.00425. So you know that 1 plus the yearly interest rate to the power of 1 is equal to this to the power of 12. So usually we have to play around with our powers, but I'm happy out with the 12 over there. I just want to get I on its own. So I just bring this plus 1 to the other side and it becomes a minus 1. You just plug it straight into your calculator and the yearly interest rate must be 0.052209. But you want to give your answer as a percentage, so you multiply by 100, it's 5.2209%. And remember, that 0, it's between a 2 and a 9, so it's considered a significant figure. So that is the 5 significant figures, and that's your 10 marks for that one. Okay, so I want to spend a bit of time explaining this one, because I think a lot of people are still struggling with this. We're told that now, right, so it's 18 months after she borrowed the money. And we now know that she owes them 64,325.37. And she has decided to pay them back on a monthly basis for 10 years. That's equivalent to, that means she's going to make 120 repayments. We know the monthly interest rate that she's agreed to pay is 0.425%, or in other words, the I we're going to use is 0.00425. So there's 120 repayments, that's my interest rate, and that's how much she owes. They told me that she's going to pay them back at the end of each month, and that's important as well. Now, you need to realize that this is a geometric series. You could use your amortization formula, but you're playing with fire if you delve down that road. You should view this as, right, you have to be able to tell what day or what time the question is set. This question is set on the day that Meg decides to pay her money back. So this question is set 18 months after Meg borrowed the money. On this day, she owes them €64,325.37. That's the present value. That's the amount of money she owes them today. And she's going to make 120 equal future repayments. So it's going to be a whole bunch of future payments that ultimately will accommodate for the P, the one present value that she owes them at the moment. So you should view this as it's one present value that will be accommodated for by a whole bunch of future payments. There's going to be 120 equal future payments that will accommodate for the fact that she owes them $64,325.37. So we can come up with a series. Because I'm making repayments, I'm using the formula as a fraction. So the amount of money she owes them is $64,325.37. That is the present value. She owes them that much money today. And I know that I don't know the value of the first repayment, so we can still call it F. I want to figure out how much each one of these repayments will be. I know that 1 plus I is going to be 1.00425. And it says that each repayment is made at the end of the month. So I know that this repayment will be made in 1 month's time. Remember, I'm considering that today is the start of this scenario. So in 1 month, Meg will make her first repayment, which means that it's the future value divided by the interest rate to the power of 1, because it's 1 month in the future. The second repayment will be made at the end of the second month. In other words, 2 months from now. So the second future repayment is made in 2 months. Obviously then the third future repayment is made in 3 months. So it's to the power of 3. You should always write your first 3 terms to prove it's a geometric series. Now I know there's 120 repayments altogether. The first repayment was 1 over 1. The second repayment is over 2. The third repayment is over 3. So obviously the 120th repayment will be over 120. And that's your geometric series. We can now know my A is my first term, my OR is my common ratio, and N is the number of terms. I know what Sn is, which means I'll be able to find the value of F. So if I just simplify my series now, I know the first term is just the first one, it's F over 1.00425. The common ratio is any term divided by the previous term. In this case, 1 over 1.00425. There's 120 repayments, and Sn has to add up to $64,325.37. If you just sub that into your Sn, if you just plug it in, my only unknown is F. And if you manipulate that around, you should end up with F. The value of each future repayment will be $685.42. And there was 20 marks going for that bit. Okay, in general, people did quite well in this one. There was 50 marks going for question 9. The first part of the question, you get 5 marks, and it's basically just subbing in. They've given you y is equal to a over 2 times e to the x over a plus e to the minus x over a. And they've told you that the coordinate 0, 2 is on this chain. So that means if you sub in 0 instead of x and 2 instead of y, you should be able to figure out what the constant a is. So if you sub it in, it works out relatively easily, and you end up with a is equal to 2. There's 5 marks going for that. You have to sub in 0 and 2 for x and y. You can't sub in 2 for your a. You can't sub this in. You can't sub in 2 for your a and verify that it's true. You have to sub in x and y and discover that a is equal to 2. Again, for a part 2, there's 5 marks going for this. We now know that a is 2, so my equation is much simpler. For the rest of it, rather than calling this a over 2, it's 2 over 2, which is just 1. So for the rest of the question, we can more or less ignore it. It's e to the x over 2 plus e to the minus x over 2. They asked me to find the height of the chain when x was equal to 3. In other words, find the y value when x is equal to 3. You just sub in x equals 3, you plug it into your calculator, and to 1 decimal place, it's 4.7 meters. Notice they told you at the end of the paragraph there that x and y are in meters. So you make sure always look out for units. There's 5 marks going for that bit. Okay, there's 5 marks going for the third bit of this question. They've told me that p is the coordinate minus 2k, and they've asked me to find the value of k. Obviously, to find the value of k, you just sub in x is equal to minus 2. So if you sub in x equals minus 2, you get e to the power minus 2 over 2 plus e to the power of minus by minus 2 over 2. So minus 2 over 2 is just minus 1, and minus times minus 2 over 2 is plus 1. And it asks me to leave my answer in terms of k. So k is equal to e to the minus 1 plus e to the power of 1. And there's 5 marks going for that. Okay, there was 10 marks going for the next bit. In the next bit of the question, they've asked me to find L. L is the y-coordinate of the point Q. In order for me to find L, I'm going to have to sub in x is equal to 4. But they've asked me to prove that L is k squared minus 2. So before I even try and find L, I should try and figure out what is k squared minus 2. Now, a lot of people use their calculator for this, and it works out as 7.2 or something like that. We were very generous to you, and we gave you the marks for that, but ultimately they wanted you to do it like this. And realistically, in the Leaving Cert, if you just started plugging into your calculator like that, you probably wouldn't get the marks. So the first thing you should do is work out what is k squared minus 2. Well, k is e to the minus 1 plus e to the power of 1. So k squared minus 2 is, I'm going to multiply k by itself and then subtract 2. So I've done this one out because it's very easy to make a mistake here. It's the first term in the first bracket by the second bracket, the second term in the first bracket by the second bracket. When you're multiplying e to the minus 1 by e to the minus 1, we're using that rule of powers again that keeps cropping up. We're just going to add the powers. Minus 1 gives me minus 2. Then e to the minus 1 by e to the power of 1, minus 1 plus 1 is 0. Then e to the 1 by e to the minus 1, 1 minus 1 is 0. E to the 1 by e to the 1 is just e to the 2. And then I've got a minus 2 at the end. Now e to the 0 is 1, and that's also a 1. So the two middle terms just become 2. And then the plus 2 and the minus 2 cancel, which means that k squared minus 2 is just e to the power of minus 2 plus e to the power of 2. That's going to be my answer. But I haven't actually even attempted the question yet. The question was to find L. L is the y-coordinate of the point Q. So now in order to find L, I need to sub in x equals 4. And hopefully my answer will be e to the minus 2 plus e to the power of 2. So now I need to go just a little bit further. The coordinate, I'm subbing in x equals 4 into my function, which is e to the x over 2 plus e to the minus x over 2. If you sub in 4, your power is 4 over 2 and minus 4 over 2. 4 over 2 is obviously just 2, and minus 4 over 2 is minus 2. Which means you've worked out that if x is 4, the corresponding y value is e to the 2 plus e to the minus 2. In other words, L is equal to e to the 2 plus e to the minus 2. And in the previous slide, we're after working out that that is what k squared minus 2 is. So happy days, that means that L is the same as k squared minus 2, so it's true. And for that, you get 10 marks. Okay, there's 10 marks going for B part 1. In this one, it asks me to show that OR is the minimum point on the chain. In other words, you're trying to find the minimum turning point. You should recognize straight away that at a turning point, the first derivative is equal to 0. Or in other words, the slope is equal to 0. So if y is equal to e to the power of x over 2 plus e to the minus x over 2, I need to differentiate it and prove that at the coordinate OR, that the first derivative is equal to 0. So in order to get the derivative of e to the power of something, it just stays the exact same, and then you multiply by the derivative of the power. In other words, the power here is x over 2. You could actually view that as a half x. Okay? The derivative of a half x is just a half, which means the derivative of e to the x over 2, it stays the exact same. E to the x over 2 multiplied by the derivative of my power, which is just a half. So the derivative of e to the x over 2 is a half e to the x over 2. The derivative of e to the minus x over 2, it stays the exact same, and then I multiply by the derivative of the power, which is minus a half. So your dy dx is this. It just works out simply like that. Now I need to prove that the slope is equal to 0 at the coordinate OR. In other words, I need to sub in x is equal to 0 and prove that at that point the slope is also 0. So if you sub in x is equal to 0, you get a half times e to the power of 0 minus a half times e to the power of 0. They just become 1s, so it's a half minus a half is equal to 0. 0 equals 0, so happy days. That concludes that there's a turning point at the coordinate 0 when x is equal to 0. That doesn't necessarily mean that it's a minimum point. So if you're asked to get a turning point, a maximum or a minimum, always verify, always prove that it's a minimum point. You only get 8 out of 10 for that. We now have to get the second derivative. And in order to prove that this is a minimum point, you have to prove that the second derivative is greater than 0. So let's work now and finish the question off. Okay, so to finish this one off, and you should always do this if you're asked for a minimum or a maximum, I have to differentiate the derivative again and get the second derivative. The derivative of a half e to the x over, the derivative of e to the x over 2 is a half e to the x over 2. And then I'm going to have to multiply that by a half because there's already a half there. Then it's minus a half, and the derivative of e to the minus x over 2 is minus a half e to the minus x over 2. Same as the last time, we've already done it. Then minus a half by minus a half is plus a quarter. Plus a half by plus a half is plus a quarter. So the second derivative, simplified fully, is this. Now, I need to prove that, in order for me to prove that or, at the coordinate or, that it's a minimum point, I need to sub in the x value, and the second derivative should be greater than 0. If the second derivative is greater than 0, that means it's a minimum point. If the second derivative is less than 0, it would be a maximum point. But in this case, if I just sub in 0, I end up with 1/4 plus 1/4, which is equal to a half, plus a half. Clearly plus a half is greater than 0, so I can conclude that the second derivative is greater than 0 at the point 0, 2, so therefore or is a minimum point. Now it's really important, because if you'd gotten your second derivative in this part of the question, you need it for the next part of the question, and it would have been a lot easier to answer the next part as well. Okay, there's 5 marks going now for B part 2. But we've more or less already done it. If you finished B part 1 correctly, you've more or less already done B part 2. The question says to show that the slope is increasing, that it's always increasing from 0 to 4. From x equals 0 to x equals 4, show that the slope is always increasing. They're not asking you to show that the curve is increasing, they're asking you to show that the slope is increasing. If they asked you to show that the curve is increasing, that means prove it has a positive slope. That would mean prove that dy dx is greater than 0. But they've asked you to show that the slope is increasing. So they're referring to the rate of change of the slope, that the slope is getting bigger. Not that the slope is positive, that the slope is getting bigger. The rate of change of slope is the second derivative. So this question is asking you to prove that the second derivative is greater than 0 between x is equal to 0 and x is equal to 4. From x equals 0 to x equals 4, the second derivative is positive. It's the rate of change of slope, not the rate of change of the curve. We've already worked out the second derivative from B part 1. The second derivative is 1/4 e to the x over 2 plus 1/4 e to the minus x over 2. You could factorize out 1/4, and if you have e to the power of something, it will always be positive. If you have 1 over e to the power of something, it will always be positive. So in this case, if I sub in any x value between 0 and 4, positive, happy days. If I sub in any x value here between 0 and 4, it's going to be positive, happy days. E to the power of a positive number will be positive. E to the power of a positive number will be positive. So no matter what I do there, if I sub in any x values between 0 and 4, this will always be greater than 0. So you can just say that d squared y dx squared is always positive for x values greater than 0. Therefore, the slope is increasing. The rate of change of slope is positive. So you can say the slope is increasing for any x value between 0 and between 4. There was 5 marks going for that. The marks are essentially going for working out the second derivative. Okay, for the last part of this question, we're asked to find the average height of the chain above ground level. Obviously, when they mean above ground level, they're referring to from P to Q. Because obviously, whatever the average is there, if this change is continued, that will always be the average. You need to realize that they're talking about the average value formula. So I need to integrate, and I'm going to use 1 over b minus a, the integral from b to a of my function. And the limits, the x values of p and q are going to tell me my limits. My b is 4 and my a is minus 2. So it's going to be 1 over 4 minus minus 2, the integral from 4 to minus 2 of my function. So if I integrate this, now I've skipped a line here, so you have to be careful. The integral of e to the x over 2 would be e to the x over 2, and then you would divide by the derivative of the power. The derivative of x over 2 is a half. but dividing by a half is the same as multiplying by the reciprocal. So dividing by a half is the same as actually multiplying by 2 over 1, which means that the integral of e to the x over 2 is just 2e to the x over 2. The integral of e to the minus x over 2 is minus 2e to the minus x over 2. In other words, I would have been dividing by minus a half, which is the same as multiplying by minus 2. And then you just need to apply your limits from 4 to minus 2. You just sub in your 4 and then you sub in your minus 2, and your final answer is 3.2 meters. Okay? So now that you've watched that video, we've done 2 full papers in the last couple of weeks, 2 full paper 1s. That should be a good chunk of your paper 1 in June. So I hope you've gone through this video with a fine-tooth comb. You should now have, you should be studying those the day before your paper 1. These are all the solutions done out perfectly, so you should have the 2 different papers, your 2 different solutions. Just look at them the day before your paper 1, and hopefully it will be a lot of this stuff that you need to revise.